While the new Relic Ruby agent automatically collects many metrics, if you see large application code segments in transaction trace details, you can use the APM Agent API to add custom instrumentation to get a more complete picture of what's going on in your application. This tutorial will cover the difference between custom instrumentation and custom metrics, the different types of custom instrumentation you can use, and examples of when each type of custom instrumentation is most useful. Before I go into the different methods for adding custom instrumentation, I want to touch briefly on the difference between custom instrumentation and custom metrics. Custom instrumentation adds additional details to existing transactions in your APM account. This is most valuable when you need to know what's going on inside a specific method, class, or block of code that shows up in a transaction trace. You can also rename or segment transactions, monitor background workers, and add instrumentation to frameworks not already supported by New Relic. Custom metrics, on the other hand, allow you to report any metric that passes through your code. Typically, custom metrics are time slice data, or data with a duration that can be timed and is generally used for time series performance data. For example, measuring error rate, bandwidth usage, or garbage collection time. However, you can also use custom metrics to record event-based data. This is useful when you need to filter data based on attribute data associated with a specific event type. For example, individual browser page loads, synthetics monitor runs, or shopping cart checkout transactions. You can view custom metrics in both APM and Insights, and even explore metrics in the Insights Metric Explorer. There are several different methods for adding custom instrumentation, each with a purpose and use case to enable you to really dig into every part of your app's code. Method tracers and tracing in class definitions is one of the easiest to use and most common method in Rails. You can add a method tracer on a method of any class, and the agent will insert an additional segment in your transaction trace anytime a particular method gets called. Method tracers can be used within normal class definitions as long as the target method has been defined first, or you can reopen the class in an initializer and then add the method tracer. I'll go over initializers in a moment. To instrument a class method, add the method tracer in the body of the class. The custom instrumentation method is helpful when I want to know when and where a particular method is getting called, or if I think the method itself is connected to the performance problem I'm investigating or monitoring. Trace initializers. If, however, you don't have a regular class and/or the method is not available directly in the file, you'll need to create an initializer and monkey patch the instrumentation directives. You can also trace a single block of code. This custom instrumentation method allows you to wrap any chunk of code you wish with a tracer, and once wrapped, it can be broken into smaller pieces to get as detailed and specific about code performance as you wish. To do this, call traceExecutionScoped to pass the code you want traced as a block. This method is really handy when a single method is so complex that tracking overall time doesn't give enough detail, or there isn't a specific method to be traced. You can also rename transactions. Normally, the agent automatically chooses the transaction name based on the method and the class. However, if you want to change the name of a transaction while it's still running, use New Relic agent.setTransactionName and then the new transaction name. Renaming a transaction is also useful if you want to segment your transaction based on some criteria. For example, if you wanted to vary the transaction name by response format in Rails, you could also rename transactions to segment your requests around some business criteria. In my app, I turned a single search transaction into two separate search transactions based on the search method used. In this case, search terms and tags. Another example is to segment a transaction into big customer and small customer with code like this. In either example, I could begin to measure performance for a more targeted audience or use case to improve my users' overall experience. However, be careful not to set the transaction name using dynamic data or user input. Doing this could generate an infinite number of transactions, rendering your data useless, as well as causing you to lose data due to exceeding transaction limits. Tracing transaction entry points. Ordinarily, the agent will be able to identify transactions within your application. But if you're not using a supported framework, or you'd like to record transactions that the agent is not automatically recording, you can define methods as being transaction entry points. Instrumenting non-web transactions. Along with method-level tracing, you can instrument non-web transactions, such as background tasks, with the same level of transaction and error detail as web transactions. Recent Ruby agent versions will record transactions for these background job frameworks by default. Rescue, for Ruby agent versions 3.4.0 or higher. Sidekick, for Ruby agents 3.6.0 or higher. And Delayed Job, for Ruby agent versions 2.10 or higher. If you are using these frameworks, monitoring background jobs should not require additional configuration. However, if you are using a different background worker framework, you can monitor the background task by including the controller instrumentation module and using the Add Transaction Tracer directive below the method definition. After the name argument, make a hash with category task. For more information, see the docs page on monitoring Ruby background processes and daemons. In the next tutorial, I'll go through the process of adding custom instrumentation and analyzing the results to solve performance problems and monitor transactions.